consider the following argument. Don has visited Australia or New Zealand. Don has visited New Zealand, therefore Don has not visited Australia. We need to use a truth table to show that this argument is invalid, and then for part B just describe a scenario. It says describe it, it won't be many words. Describe a scenario which demonstrates that the argument is invalid. Right, so we need to, if we set this up kind of logically, or before that, just even sort of words logically, so we have the premise, which is Don has visited. Don has visited Australia or New Zealand. Okay, and then Don has visited New Zealand. This is sort of the given piece of information. Don has visited New Zealand. New Zealand. Therefore, Don has not visited Australia. Okay, so it sounds a bit like a dodgy argument already, just even saying it out loud, but we'll do it properly. So we have the two bits in the premise, and then we have the conclusion that we arrive at. So if we are going to have to define a proposition P and a proposition Q, so let's say P can be Don has visited Australia. Australia. And Q is going to be Don has visited New Zealand. Okay, so our argument needs to look like this. So it's, remember, everything in the premise needs to be true in the conjunction, so this and this, and then we need to see if this and this implies the conclusion. So we're looking to see the first one written in terms of P and Q, so is Don has visited Australia or New Zealand, so that's disjunction, so that would be P or Q. So that's the first one. And we also need the second proposition, which is just Don has visited New Zealand, which is Q. And remember, everything in the premise needs to be true, so that means the two things in the premise in conjunction. And we then need to see if all of that implies the conclusion. The conclusion being Don has not visited Australia, so that must be the negation of P. So we're going to now construct a truth table for this, and we start simple. You start with P and Q. P and Q, just like that. So it's true, 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 false, false, true, false, false, standard layout. And then think, well, what are we going to need? We're going to need quite a few other things going forward, because we want our last column to look like this. So we're probably, we're going to need a not P, definitely. We're going to need a P or Q, and we're going to need this as well. So let's have a not P. That's easy enough. So negation of P is just the opposite, so false, false, true, true. Right, so we'll use that later. Then we're going to need a P or Q, so the disjunction of P or Q. P or Q. Remember, this is it's when either P or Q or true or both are true, then this is true. This is only false. The disjunction is only false when they are both false. So that happens here. Everywhere else, they're either both true or one of them is true. So one or the other or both, which is what that means. So true, true, and true. So now Well, we're going to need this bit here. So P or Q and Q. So P or Q and Q, like that. So now we need to consider these two columns. So the P or Q column and the Q column here, and they both need to be true for it to be true. So that happens here and here. So that would be true there and here as well. Anywhere else, remember it's P or Q and Q. So here one's true but the other one isn't. And here they are both false. So that would make this false and false. Okay, so now we can do our final column, which is this P or Q and Q. Does that imply the negation of P? So remember, an implication, one thing implying the other, is only ever false when the first one is false and the first one is true and the second one is false. So we are looking for cases where we're looking to see where this column implies this one. So there's the P or Q and Q column imply the negation of P column. So that will, here this is true and this is false. You can see straight away it's false there. Right? False, false, we call that true because it's inconclusive. True, true, definitely true. And false, true, well, whenever this is false, it will be true for the same reason. So true, true, true. So now we can answer the question being, is it a valid argument? And no, it is not valid. For this to be valid, you need all of these to be true, which is called a tautology. So not a valid argument. Not a valid argument, as it isn't a tautology. Okay, so that was A, the end of A. For part B, describe a scenario that demonstrates that the argument's invalid. So if you just think about the argument, anyway, it's saying Don has visited Australia or New Zealand. He's visited New Zealand, so that means he hasn't visited Australia. Well, what if this Australia or New Zealand? Well, that both would cover that, because remember, this is Australia or New Zealand or both. So if he had been to both, then this would still be true, this would be true, this would be true, but the conclusion would be false. So if he had been to both Australia and New Zealand, that would be a scenario where everything in the premise was true, but the conclusion was false. So Don went to both. Countries. Okay, so it just asked me to describe the scenario that demonstrates that it's invalid. So the argument falls down on that particular scenario.